All right, this is the chapter review for chapter test 2. So working on page 88, okay, this is number 40. The question is this: y equals negative absolute value of x minus 3. Okay, so we can see we have an h value of negative 3. If you remember what we talked about, y equals the negative absolute value of x minus h plus k, where h is my horizontal translation and k is our vertical translation. So I have a negative 3 or minus 3, so my 3 is positive, so I'm going to move to the right 3 units. I have no k value. I have no value outside the absolute value over here. So I'm able to plot that point. The parent function, if you remember, the parent function of this equation is nothing more than y equals the negative absolute value of x. So we're going to have a slope of negative 1 and positive 1. So here's my positive 1 slope. And here's my negative 1 slope. So there we go. That's number 40. Number 41. Let's just erase it real quick and move on. Number 41 is this. Let's set it up. Okay, number 41 is this: y equals the absolute value of 2x plus 6. Okay, well, if you remember a while back, we had an equation. Our vertex is nothing more than negative b over m comma c. Well, my b value happens to be 6, and my m value happens to be 2. And my c value, there's nothing outside the absolute value, so 0. So that would be vertex of negative 3, 0. Okay, since this doesn't really follow a nice parent function, let's go ahead and plot some points. So I have negative 3, 0. That's my vertex. So let's pick a number above and below that's equidistant. So 0 is an easy number to pick. So now we're going to plug into the equation 0. So let's just plug it in. So I have y equals the absolute value of 2 times 0 plus 6. So y is going to equal the absolute value of 6, so it would be 6. If we go equidistance down, if I go negative 6, again equidistance, we're going to plug that into the equation. What you're going to see is we're going to get y equals the absolute value of 2 times negative 6 minus 6. So y is going to be, plus 6. Negative 12 plus 6. So y is going to be the absolute value of negative 6, which is 6. And again, if it's equidistance, my y value should be the same. So let's plot the 3 points. Okay, so I got negative 3, 0. So I translate to the left 3 units. Okay, when x equals 0, y equals 6. So we can plot that. And when x equals negative 6, y equals 6. So I can plot that. So there's my inequality. It's positive absolute value, so it should be going up. So there we go. Number 41. Okay, moving on. Number 45. Here's the equation. Y equals negative absolute value of negative 2x minus 1 plus 1. So my vertex is negative b over m comma c, which would be negative 1 over negative 2 comma 1. So that would reduce to negative 1/2 comma 1. So that's my vertex. So let's just plot a point above and below. So we'll set our xy columns. We'll put a vertex at negative 1/2 and 1. So let's go 1.5 units above. So that would give us a value of 1. So let's just plug in 1 and see what happens. Y equals negative 2 times 1 is negative 2 minus 1 plus 1. So what is negative 2 minus 1 would be negative 3. So y would be negative absolute value of negative 3 plus 1. Well, the absolute value of negative 3 is 3, so y would equal negative, because of that negative, 3 plus 1, which would be negative 2. So I went 1.5 above, so let's go 1.5 below. That would be negative 2. Okay. So we can plug that one in as well. Again, we're using this function right here, this graph. Let's do it in red. Y equals negative 2 times negative 2 minus 1 plus 1. Negative 2 times negative 2 is positive 4, so I get 4 minus 1, absolute value, plus 1. So 4 minus 1 is 3. The absolute value of 3 is 3, so it's going to end up being negative 3 plus 1, which would be negative 2. So there we go. We got 3 points. So let's graph or plot the 3 points. The vertex is at negative 1/2, 1. So there's our vertex. 1 point is at 1 comma negative 2, so move 1 down negative 2. The other one is negative 2, negative 2, so move 2 down 2. And there we go. Get your straight edge out and draw your graph. So I have a vertex at this one at negative 1/2, 1. Okay, moving on. Number 61 says, what is the vertex? What is the vertex of y equals the absolute value of x minus 5? Again, so y is going to equal x minus h plus k, where our vertex is h comma k. Well, looking at the equation, my vertex, my h value, let's just look, h minus k. There's nothing inside the absolute values but x. So my vertex is going to be 0 for the x-axis. All right, and y, my k value plus k, my k value is minus 5. So my h value is 0, my k value is negative 5, so my vertex must be 0, 5. Okay, 63, next one. What is the vertex of y equals the absolute value of x minus 3 plus 5? Okay, the equation we learned was y equals absolute value of x minus h plus k. Well, my vertex is nothing more than my h and k value, so my vertex is 3 comma 5. Okay, that somewhat covers what we're going to see on the test for 2.5. Let's go now to 2.6. These things are on page 95 to 98. Number 1. It says compare the graphs of each pair of functions. Describe how the graphs of the second function relates to the first. So I got y equals negative absolute value of x. And then I got y equals negative absolute value x plus 3. Well, we're basically going to move this thing up. We're going to translate it or shift 3 units up. How do I know? Because there's the difference. Remember, our equation looks like this. Y equals the absolute value x plus h plus k. So you see a plus k. So number 1, we're just going to translate it or shift it 3 units up. Number 17. Write an equation for each horizontal translation of y equals absolute value of x. So our graph that's drawn already looks like this. Okay, So how many units are we translated here? Sorry about that. Well, let's count. 1, 2, 3. So my equation is y equals the absolute value of x minus h plus k. So my h value is 3, so this is going to be y equals the absolute value of x minus 3. Okay. Number 19. Number 19 says this. Or sorry, not 19, number 24. Says y equals the absolute value of x minus 1 minus 2. Can we graph that? Well, what's the parent function? Y equals absolute value of x. All right. What was the equation we learned? Y equals the absolute value of x minus h plus k. So our h value is just 1. Our k value is negative 2. So h is 1, so we're going to move right 1, and k is negative 2, so we're going to move down 2. And it's just a parent graph of its parent's graph is y equals absolute value of x. So at the vertex, we're going to have one line with a slope of positive 1 going up, and we're going to have another line with a slope of negative 1 going up. So there we go, with a vertex of 1, negative 2. 28. Write an equation. So we don't need a graph. Write an equation for this translation. Y equals the negative absolute value of x, 2 units up, and 1 unit to the left. Okay. So my h value is going to be negative 1, and my k value is going to be 2. So my base equation is y equals negative absolute value of x minus h plus k. So let's just plug it in. Y equals negative x minus negative 1 plus 2. There's your equation. You have a translation of 1 to the left and 2 up, and you're going to have a slope going down, or a graph going down. So plugging along. Number 38 says, describe the translation as vertical, horizontal, or diagonal, and then graph. So I got the function of x equals the absolute value of 2 plus 4 minus 2. Well, our base equation is y equals absolute value of x minus h plus 2. So my h value in this case must be negative 4. And my k value must be negative 2. Because the only way I could get it to be x plus 4 is to make it x minus negative 4. So I have my vertex. I have my parent function of y equals absolute value of x. So now let's graph it. Okay, all we have to do is plot the vertex. My h value is negative 4, my k is negative 2, so let's move negative 4 left 4. 1, 2, 3, 4, and down 2. So there's my vertex of negative 4, negative 2. This thing has a slope of 1 and negative 1 going through it. So there's my slope of 1. There's my slope of negative 1. Okay. Okay, going to page 102 through 104, working on chapter 2, section 7. So page 102 through 104 now. Okay, number 5 says this. Graph each inequality. 2x plus 3y is greater than or equal to 12. So first thing, let's get y by itself. So Let's subtract 2x to each side. So I'm going to get 3y equals negative 2x, sorry, not equals, is greater than or equal to negative 2x plus 12. Now divide each side by 3, or divide each term by 3. So I'm going to get y is greater than or equal to negative 2/3 x, that's my slope, plus 4, that's my y-intercept. So let's plot points. My y-intercept is at 4. My slope is negative 2/3. So that gets down 2, left, right 3, 1, 2, 3. Up 2, left 3, 1, 2, 3. Okay. It's greater than or equal to, so I can draw a straight line. Okay. I'm just plotting points. So I can draw a solid line. Again, I recommend using a ruler and straight edge. And I would highlight above because it says y is greater than or equal to. So it's a solid line. And just color it in. Nice and easy. If you're like me and you're using a Surface tablet, you can go crazy on the highlighter ink because you're not going to run out. And I just like to rewrite the equation inside of it. Y is greater than or equal to negative 3/2 x, or sorry, negative 2/3 x plus 4. Okay. Going on to number 8. Okay, number 8 says this. Graph the inequality. 3x minus 2y is less than 9. So we're going to subtract 3x to each side again. So that's going to give me negative 2y less than or equal to negative 3x plus 9. Divide everything by negative 2. Okay. What's going to happen to inequality sign? We got to flip it. So I'm going to have y greater than or equal to, what's negative over negative? So it's just going to be 3/2x minus 9/2. Okay, so I have a y-intercept of negative 9/2, which is negative 4.5. Okay, and I have a slope of 3/2. So up 3/2. Up 3/2. Up 3/2. Okay, so now I have enough points to plot my line. And I'm going to graph, it's greater than or equal to, so solid line, and I'm going to graph above it. Okay? And again, I like to go ahead and write the equation in the highlighted area, or in the shaded area. So my equation is going to be y is greater than or equal to 3/2 x minus 9/2. Okay? To number 14. This one says graph the absolute value inequality. So I get y is greater than the absolute value of negative x plus 4 plus 1. Okay? So I can find my vertex a few different ways. Okay? My vertex could be negative b over m comma c. Okay, my b value is positive 4, my m value is negative 1, and my c value is 1. So negative 4 over negative 1, my vertex is 4 comma 1. Okay, so let's plot that. 4 to the right, up 1. So there's my vertex. Okay, it's a parent function of basically y is greater than the absolute value of negative x, which is absolute value of x. So we're going to have a slope to the right of a positive 1. And we're going to have a slope to the left of a negative 1. So it says y is greater than the absolute value of negative x, so we're going to highlight above it. And it's a dotted line because the inequality does not include the word equals to, or at least. So there's number 14 for us. Okay, now we're going to work number 19 under the same concepts. Graph each absolute value. So I got y plus 3 is less than or equal to the absolute value of 3x minus 1. Before we do anything, let's subtract 3 and get y by itself. So I'm going to get y is less than or equal to the absolute value of 3x minus 4. Okay, my vertex is going to be 0, 4. Sorry, negative 4. 0, negative 4. And if you don't see that, you could go ahead and go negative b over m, comma, c. My c value is negative 4. My b value is 0. So there's my vertex. Okay, so my vertex is 0, negative 4. So we can plot that. Let's go ahead and set x and y values, since this isn't a easy function per se. Isn't easy as far as it's not a parent function, it's just absolute value of x. So all we have to do is pick a number above and a number below. So let's pick x equals 2. So we plug in y is greater than or equal to 3 times 2, absolute value, minus 4. So 3 times 2 is 6. Absolute value of 6 is 6. So 6 minus 4 is 2. So if I go 2 below and I go negative 2, I'm going to have the exact same answer because we picked the equidistance point. So let's plot 2, 2. And let's plot negative 2, 2. So there are my 3 points. Okay, so let's look at the inequality we set up where it was just y by itself. It's y is less than or equal to. Y is less than or equal to. So that means I can draw a solid line. And I have a narrow slope, which makes sense. And I'm going to shade everything below because it's less than. All right. So there you have it. And again, you can tell I didn't get high grades on coloring in the lines in grade school. All right, going to number 30. The problem says the absolute value of x minus 1 is greater than y plus 7. So let's get y by itself. So let's subtract 7 to each side. So I'm going to have y is less than absolute value of x minus 1 minus 7. Okay, does everybody see what I did there? I just read it from y. So on this side I said y is less than absolute value of x minus 7, or x minus 1 minus 7. So over here on the right side, y is less than the absolute value of x minus 1 minus 7. So I said it the same way. Okay? So now we just got to find our vertex, which our h value is 1, our k value is negative 7. So our vertex is 1, negative 7. So let's plot 1, negative 7. There's our vertex, 1, negative 7. Okay, it's a dotted line because it's just less than. It's the parent function of y equals absolute value of x. So the slope on the right side of this line is just 1. So we can just do a dotted line all the way up at a slope of 1 over 1. The left side of the equation, the left line, is got a slope of negative 1. And again, we'll do a dotted line with a slope of 1, negative 1, all the way through. Okay, now it says y is less than, so we're going to shade below. We're going to shade less than, so we're going to shade in below the line on both sides. Okay, so there you go. There's your equation. There's your vertex. Y is less than the absolute value of x minus 1 minus 7 with a vertex of 1, negative 7. And it's a dotted line in the inequality, and we're shading below. 39. The question says this. Write the inequality for each graph. So we've got a line. Okay, so my base equation for a line is y equals mx plus b. I have a y-intercept of 2, so my b value is 2. See if we can find the slope. Looks like I have a point here, so it looks like I can go up 1, 2, 3, and over 2. So it looks like my slope is rise over run of 3 over 2. So I got y equals 3 over 2x plus 2. All right, well, it's an inequality, and it's shaded below, so y is going to be less than or equal to 3 over 2x plus 2. Okay, so we graph the linear equation, and then we change the inequalities. Okay, number 41. Okay, we have a v, so that tells us it's going to send an absolute value equation. We have a slope of positive 1 and negative 1, so we know the parent function's absolute value of x. So y is going to equal the absolute value of x minus h plus k. Well, my horizontal translation is to the left 2, or negative 2, so that's going to be y equals the absolute value of x minus negative, see what I did, I made a sign, positive sign, minus negative 2, and my k value is 0. There's no translation off the x-axis up the y. So there's my equation. Okay, but again, it's an inequality. It's less than because it's below the line, and equal to because the line is solid. So we're just going to change it to make a y less than or equal to absolute value of x plus 2. Okay, 43. Again, I have a positive slope of 1, a negative slope of 1, and I have a v, so I know it's absolute value sign. So y equals the absolute value of x minus h close plus k. Well, I've translated 1 unit to the left, so my h value is negative 1, and I've translated 1 unit down, so my k value is negative 1 as well. So I get y equals the absolute value of x minus negative 1 minus 1. So there's our equation, but it's an inequality, so get rid of the equals. It's greater than, okay, the line's dotted, so it's no equality, no equal to, so it's just going to be y is greater than the absolute value of x plus 1 minus 1. Okay, moving on to number 45. To raise funds, the junior class plans to sell frozen yogurt cones and sundaes. Each dessert contains 1 scoop of yogurt. Write an expression to represent the number of scoops of yogurts used in making C cones and S sundaes. So part A, it's pretty straightforward. Since each of them takes 1 scoop of yogurt, the total amount would just be C plus S for cones and sundaes. So part B, suppose you have enough yogurt for 200 scoops. Write an inequality to represent all the possible combinations of cones and sundaes. So cones plus sundaes is going to be less than or equal to 200. Part C, graph the inequalities. Okay, so we'll make the vertical one cones. We'll make x equal to, or y equal to cones, and x equal to sundaes. Okay, I'm going to highlight that so we can see it really easy. I made each tick mark represent 20. So let's look. If I sold 0 cones, I would have to sell at least, or at most, 200 sundaes. So let's mark that spot. And conversely, if I sold 0 sundaes, I would have to sell at least 200 cones. So I can draw those. I can graph that. Okay, so I've connected the dots. I don't have enough yogurt to make more than 200, but I can make less than 200 all the way to make absolutely nothing. So now you notice, again, each tick mark represents 20. The y-axis or vertical axis is my cones, my number of cones, and my x-axis is Sundays. So question C, graph the inequality. Is point 20, 50 a solution? So 20, 50. Yes, it is. So 20, 50 falls within our range. On your graph, find the point representing 60 cones and as many Sundays as possible. What does the S value at this point represent? So 60 cones. So there's 20, there's 40, there's 60 cones. And the most Sundays I could sell is right there. So what would that be? Well, that's 200. So that would be 180. That'd be 160. So that'd be 140. So that point represents 60, 140. It is on the line. Okay? And you could plug that back into your inequality just to see. So it said 60 cones. So I have C plus S is less than or equal to 200. C is 60 cones plus S less than or equal to 200. Subtract 60 to each side. So my Sundays would be less than or equal to 140, which is exactly what we got here. Okay? That's what the S value represents. Okay, that's your review. If you can do these 19 problems, you'll do absolutely great on this test. Okay, don't forget to study your Moodle motivation as well.